Good day, learners. In this week, our strand will be numbers for everyday life. We may ask ourselves, why is everything about mathematics numbers? Okay, but one thing you need to know, mathematics is not just about numbers. It's about problem solving. Now, coming to numbers. What is your favorite thing to do? Think about it and write it down. Well, I believe you wrote eating, sporting, gaming, watching videos, reading. These are some of the things that students like, including me. I like this as well. But then ask yourself, why do you choose it as your favorite? Yeah, maybe because of happiness, to release stress, love, or talent. Yes, we all choose things, some things as our favorite because of some of these qualities that we get from them. But the question is, why didn't you choose the other activities? Because other activities to give you some of these qualities as well. You agree with me? Okay. Now the answer is quantity. It's the quantity of the quality you get from them. Someone might have chosen eating instead of sporting because you get a lot of happiness in eating as compared to sporting, or vice versa. So if that is your case, what do you think about it? So this could make it important and necessary for us to be using numbers, because numbers, whether you like it or not, are very much important in our everyday life. A farmer uses numbers, sellers, our traders, use numbers in trading, in selling and buying. The doctors you want to become, they also use numbers in medicine. The amount of drugs you take, you can't go beyond a certain quantity, and that is number restriction. So number is very much important in our everyday life. Now, what are all these numbers? What are all these numbers? What will help us to answer this is a follow-up question. Let me ask you, think of any number you believe does not exist. Obviously, it's impossible to think of a number that does not exist, because a number you think of do exist. And this brings about the real number system. Everything about number is the real number system, even including the numbers that we imagine to exist. All have some sort of reality in them. So for this week, we'll be looking at the real number system, and that will be our strand, our sub-strand. Name all class or group of numbers you know. I believe you all know some numbers, so name them. Okay, I believe your number included natural numbers, whole numbers, integers, rational numbers, irrational numbers. Don't worry if yours wasn't mentioned, but you need to know every number that you have mentioned, in one way or the other, they fall within these categories of numbers that I've written here. Now, what then are natural numbers? Okay, in your group, look at what natural numbers are, what whole numbers are, and what integers are. Perfect. Natural numbers are counting numbers from 1 to infinity. Whole numbers start from 0 to infinity. Integers are all negative and positive numbers that we may think of. All negative and positive whole numbers, they are all integers. Then, remember earlier on that we have identified some class of numbers, and note that all the class of numbers that we have identified are all subsets, meaning they are under the set of real numbers. For example, we are all Ghanaians. We are Ghanaians. And Ghana is in West Africa. So that means that a Ghanaian is an African, because a West African country is a region, a sub-region in Africa. So we can make a conclusion to say that Ghana is inside Africa. So the same way, also the same application can be related to these examples of numbers that we have mentioned. Now, why then do we try to establish the set of real number using the closure? So this brings us to our lesson for today, establishing the set of real numbers using the closure. Closure, which is a property, what it says is that supposing we have a tree, we plant a tree. Akosia, who is a farmer, plant a tree in a garden. She nurture the tree and expect the tree in 10 years to come to become a working human being. What do you think of Akosia? What will you say Akosia is? You will say, obviously, Akosia has something wrong with the mind. Yes, because we expect that a tree should grow up to be a tree, a mature tree. And if it should bear fruit, then it should bear fruit that will be eaten, or that will still continue to reproduce. The same way, the same thing applies to set of real numbers. We have 4 different operations which we see that when operated, when 2 real numbers or more operate, then they should result, we expect them to result in another real number. So if we do that, if that happens, then that means we are in closure. But if the opposite happens, if we do not get a real number, then it is not closed. Let's take numbers for instance. Perhaps we might not get it. So we're taking numbers. Think of any real number that you know. I'm sure by now you know what real numbers are. Good. I pick 5. 5 plus 5 equals 10. And we know 5 is a real number. We add it to another 5, which is also a real number. This should be equal to 10, which is also a real number. No matter how many numbers we take when we add, we still be getting real number. So that means real numbers are close under addition. The same 5 is also a whole number. So we can say that whole numbers are also close under addition. The same number is also an integer. So we can say that integers are close under addition. Right. We can further move to subtraction. 5 minus 5 equals 0. 0 is a real number. So we can conclude real numbers are close under subtraction. We might even change the number as well to 5 minus 6. We get -1. -1 is a real number. So real numbers are still close under addition. We move to whole number and see whole numbers by whole numbers is not always whole numbers, because we've seen that 5 minus 6 equals -1. So 5 minus 6, -1, it's not a whole number. So this is not always close. So this is not close. We can do the same for integers. Integers minus integers equals integers, because we can still get negative values and positive values. And know that all negative and positive whole numbers are all integers. We could repeat the same practice for the multiplication sign. So 5 times 5 equals 25. So if 5 times 5 equals 25 and 25 is a real number, then we could say that real numbers times real numbers are close no matter what. The same thing also applies to whole numbers. Whole numbers multiplied by whole numbers will always be whole numbers. The same thing also applies to integers. Integers multiplied by integers will always be integers. I believe by now you've understood what real numbers are. Good. Now, division. 5 divided by 5 equals 1. So it's whole number. So does that mean that real numbers divided by real numbers always gives us real numbers? Wait a minute. Let's check 0. When you have 5 oranges and you want to share it to nobody, to no group at all, how many oranges will the no group get? Obviously, it doesn't make sense. You can share 5 oranges to a no group. So if you can share 5 oranges to a no group, that means that the no group will not be getting a number. We can't have a number for a no group. So not a number. So a no group is getting not a number. And not a number in mathematics is represented with a sleeping 8, which is referred to as undefined. Now, undefined is not the same thing as infinity. We'll be knowing that we'll be getting to know that in our lessons to come. But do not forget to like, share, and comment. Okay, we'll still continue. Then, if real numbers are not close on the division, that means all the subsets will never be close also, because real number is the parent of all the rest of the numbers. Does it make sense? Good. So whole numbers divided by whole numbers will also not be always whole numbers, so not close. Integers divided by integers will also be equals to not close. I guess by now you're familiar with the closure property. Good. Now then, what are real numbers? What are real numbers? Good. Real numbers are numbers that can or cannot be expressed in the form A on B, where B is not equal to 0. We can also say real numbers are the combination of rational and irrational numbers. Perfect. I believe you also have said in your definition, you might have said that real numbers are all the numbers that exist. Good. That is not bad. Now, where do you think these numbers are applied? Yes, of course, they are applied in temperature reading, in medicine, in agriculture, in computing, in business, and in food and cosmetic industry, and many more. So, we can then classify the subsets that we've mentioned. We can then group them as follows. This is shown on the flow chart on your screen. So we have real numbers, which is broadly divided to rational and irrational. Then we have the irrational numbers, which is broadly grouped into sets or non-terminating, non-recurring decimals, or pi and pi as well. Then for the rational, we have broad divisions of fractions and integers. The fractions are narrowly divided into terminating decimals and recurring decimals, and that's where it ends. For integers, we have negative and whole numbers. Then the whole numbers are broadly divided into 0 and natural. Good. Now let's see this short exercise. We will try to represent numbers on number lines. So you represent the following numbers on the number line drawn: -3, 1.5, 1.75, -4.25, -1 on 2, -7 on 2. Put yourself in your group and do that. Alright, let's see what you've done. So for -3, you start counting, you start from 0 then you make a movement to your left. Those are negative values. Movement to your right are positive values. So this is negative 3. So we have 1, 2, and 3. So 3 movement to our left, and this is negative 3. So we have here negative 3.5. So we have indicated that. Next is positive 1.5. Start from 0. If positive, you move to the right. So 1.5 is positive. So we move 1, 2, but it's 0.5. So 1. So 0.5 will be between 1 and 2. So you have here. So 1.5. So we have 1.75. The same way we did for the second. So 1.575 will be between 1.5 and 2. So this is 1.52. So we can put it anywhere you see, anywhere that seems between 1.5 and 2, depending on your site view. Okay, so we have this 1.75, negative 4.25. Start from 0, 1, 2, 3, 4 to the left, and 2, 5. So that will be between 4 and 5. So it wouldn't be, it's not up to 0.5, it's not up to half. So it will be between the 4.5 and the 4. So you have here. So here as well. So negative 4.25. I hope you had it. Good. The same thing with negative 1 on 2. For negative 1 on 2, it's a fraction. So since it's already in whole, since our numbers are already written in whole, it's better we change the fraction to wholes. So in changing to wholes, this is a fraction, so it will be a decimal. So negative 1 on 2 should be equals to negative 0.5. So you have 0, you move to the left. It's not up to 1, so it will be between. So you have here negative 1 on 2. So you have negative 1 on 2. Good. We do the same thing for negative 7 on 2. Negative 7 on 2, which should be equals to negative 3.5. Do the same, start from 0, move 3 units to the left, and you have 3.5. Oh, 3.5. The first one is negative 3. I wrote negative 3.5. Okay, sorry. So 3.5. So we have this. So negative 3.5. And that is that. I hope you had it. Good. Alright, so thank you, Maths with Demi. Have a nice day. But we'll meet in the next lesson. See you there.